we're more than happy to host our little coming out party with the technical solution that we've been working on here for about 1.5 years, and you are bang on target. On top of reading from my slide, of course, that what we're concerned about is scalable management of applications on what we call the distributed edge. And we'll spend these actually 2 hours in trying to make sure that you understand why we're here, where we're from, and we're going to take you on a little demo journey to make our pieces of software here come alive in front of your very eyes. So I usually go a little slow and a little kind initially here, and I will also start, by the way, by saying that I am Carl Moberg. I am the CTO over at Avassa Systems, and I brought with me today here my colleague Fredrik Jansson, who will be actually driving the technical aspects of the demo, which is actually a significant part of the presentation. But we're going to start a little slow because I want to take you through the moving parts and the rationale behind the company before we speed up a little bit and actually build a scenario and show you our software. So in brief, what we've seen, starting on the left side of this slide here, is that obviously people kind of like the public cloud. And most of the enterprises and most of the users and most of the service providers we talk to are in some capacity on their way towards the public cloud. Now, both Fredrik and I have a long background in automation and orchestration, notably perhaps in infrastructure and precisely actually in networking. So we have a good idea for how to build automation systems. And when we look at the public cloud, there's a couple of things that kind of hold true for that environment. And in our mind, the most important part of that is actually the fact that public clouds are built on many computers in few data centers, right? So many computers in very large locations in each data center. And there's fast and cheap networking in each of these data centers. And the tools used to manage applications in these data centers are usually based on utilization, efficient utilization of the available hardware resources. And location is not really a first-class citizen or a core concept in the abstractions provided by these platforms, because why would they? They don't actually have to be, as long as you adhere to the public cloud paradigm. But over the years, we've talked to a lot of enterprises and actually some service providers that are driven towards the right side of this slide by a number of reasons, right? And we're not taking any favorites here. We're just observing that there are several things that are kind of pushing towards the right side. And we hear things like autonomy and resiliency needs, meaning that we need to have the compute close to where things happen with other machines or humans. There's privacy and regulations, which is probably the more fluffy side of things, but nevertheless a very important aspect of, for example, government operations and several other things. And for our technical friends, there's of course things like predictable latency, i.e. ping response times, and the fact that there's a decent data explosion happening in some of the industries that we've been surveying. So I'm thinking about that part more as a Brownian gas motion. There's not one kind of thing that's pushing towards the right. There's a whole slew of reasons why we see users kind of looking over at the right side here. And when we talk about the right side, we're struggling with terms, just like all companies, it turns out, in the edge environment. But we call this the distributed edge cloud. And the way we define it is to say that there are few computers, maybe a handful, maybe a rack, in many locations. And you know what? They don't even have to be physical. But there are fewer computers, but in many, many more locations. So think public cloud, gigantic amount of computers, few locations, the distributed edge, few computers, but many locations. Things thousands, tens of thousands. We even have users that are playing with the idea of having millions of locations, if you think about set-top boxes, for example. And of course, with that comes the fact that applications and their data is distributed across all these locations. And if you have many locations, you can bet that the network isn't always up and running. If you think about retail, for example, and you look at the backhaul from retail locations, you can bet that they haven't really overspent on diverse data paths, right? So they know that there will be intermittent networking here. And location is actually fundamental. There's a point to reason why they've put these computers in this particular location. And the reason for that kind of varies a little bit across industries, but it's important, of course, that location in itself is a kind of a first-class citizen in the way you think about applications and where to place them. So our intent here, our vision is to tie together the public cloud paradigm with the distributed edge cloud paradigm and make that as easy to access and as lovable as the public cloud has turned out to be. And so that's kind of the arrow at the bottom here with the Avassa logo. And there's a reason why it kind of stops short of the devices, which is to say, and you will hear us talk about this, we stop roughly roundabout where general compute stops. So we're not a firmware upgrading machine for your cameras. As long as the computer you're looking at can run, let's say, 2 container-based applications in a useful fashion, we can be useful. So that does scale down to a Raspberry Pi if you think that's a useful way of running your applications. Okay, so that's what we're going for here. Let's move on. So when we started digging into what needs to be done, to actually create such a useful bridge or something that actually provides a nice abstraction for a distributed environment, we realized that there are 2 buckets of tasks, if you like, here, right? The lower left, someone is going to be tasked with running the sites, the actual computers that the applications are supposed to run at, right? So they're tasked with making sure that these sites are available, up and running and ready to take on applications. Needs to be a low toil management approach. As you go to hundreds or thousands of sites, you don't have much leeway or flexibility to do heavy, one by one or even worse truck roll operations in all these places. And at the core of this is, of course, to make all these sites emerge in front of the upper left team, which is the application bearing people that want to deploy applications, make it actually look like a consistent whole as an actual distributed edge cloud, right? So they can reuse their tools and processes and all their experiences that they have from their private clouds or from the public cloud and deploy their applications in the same ergonomic and friction-free way across a very distributed environment as they do with these very centralized environments. And when we started unpacking that, of course, we realized that it's not just about copying computer programs in container packaging and starting them in many locations, right? In order to reliably run application operations, we have to think through what it means to do monitoring and observability if you're in thousands of locations. What does it mean to provide graceful degradation in terms of autonomy and resilience? If you lose upstream connectivity, how can we keep applications alive if they don't have internet access and, for example, therefore not DNS resolvable? And this one was huge for us. What about security? Some of these sites may actually not even have physical integrity or physical protection. They may be hanging off of light poles. How do we protect applications and data? How do we measure consumption? Some of our users want to measure consumption to follow up on cost, or even more interesting, to actually charge for access to their edge site. And how do we provide nice and efficient shared execution, for example, in multi-tenant environments, where you may even have adversarial tenants running on the same compute with applications? So we realized that this is a pretty fundamental, pretty cool and tough undertaking to make the distributed edge cloud come alive and actually make it into something that traditional DevOps or application developers can actually love instead of fear or not want to work with. So that's kind of what we're striving for here. So we've built software. That's what companies like we do. We software our way out of things. And we've built 2 pieces of software. And you guys will be led through many details about these 2 things. But for the first time, I present to you the Avassa Control Tower, which is the single point of entry for humans and machines that want to interact with the distributed edge cloud. And the second piece of software that we've built is called the Edge Enforcer. The Edge Enforcer is actually a container application that a user installs on each host in each site that are to constitute the distributed edge cloud. And it's got a fundamental role as a piece of our infrastructure. And it also provides a number of application and operation facing features. So these are the 2 softwares that we'll talk about today. The control tower can be either consumed through something we call the Avassa Cloud Platform. So our users can start one of these in our ACP, and that's actually how we're going to run our demo. later today, but it's also available as an on-prem solution. So, and we see a number of strong opinions on how to do that in the industry. But today we'll focus on an environment where we run an uncontrolled tower instance out of our ACP platform. And the way this kind of fundamentally works, just maybe to make it come alive a little bit with humans, is that as someone running an edge cloud, you start by onboarding your distributed compute resources, meaning you install your edge enforcers. You assign compute resources to users. And we see some of our users like kind of sharing the operational responsibility for running the distributed sites and managing the applications in the same person, while other users have a distinction between who's running the edge enforcer-based sites and the applications. So either which way, you assign compute resources to someone who wants to deploy applications, and they go ahead and they manage the applications on their assigned resources. And as we built this, of course, we came across many really cool and interesting challenges, and that's why we're so excited to show you the result today here. It takes a little bit of thinking and architecture to make this an autonomous system, or a system that can provide autonomy for the edge sites. We really wanted to make the sites self-organizing, so we'll show you that by actually having a self-organizing or a centrally configured setup or architecture, the amount of work you have to put in to actually manage the edge sites is minimal. We need this to be massively distributed. We'll show you what we believe to be a small setup today, which is about 100 sites. We know we can scale further, but it takes a little bit more preparation. It's a little bit harder to show. We wanted to build a really lean edge footprint. Some of our users scale down to pretty small compute. Our edge enforcer is about 200 megs, so we can really scale well down with compute platforms. And we needed this to be multi-tenant, meaning that you can have, again, many users deploying applications at the same time, and we need deep isolation between them so they can do that in parallel without impacting each other. And before we go into the action, I just wanted to kind of wrap it up here and kind of open up a little bit on the technical side. Control tower. We will look at the web UI. We will look at our command line interface. We will look at our REST API. I think you guys get it intuitively. That's where you interact with the system. The edge enforcer, again, is a little bit more of a more complicated beast. It has two kind of distinct roles. Number one, it is an integrated part of our infrastructure, right? So when you actually install this, and we will show this, it calls home to its control tower. It identifies itself and it receives the configuration needed. And optionally, it can form a cluster with other local edge enforcer instances. It then proceeds to take over application placement and scheduling. And the setup we're going to show you guys today, the current generation, runs on container runtime. So we assume that each host that the edge enforcer runs on has a Linux OS and a pre-installed container runtime. This actual example today is going to be on Docker. So that's one thing, right? It's part of our infrastructure. We quickly realized and learned that people running applications and people developing applications expect way more than, again, just being able to start an application in the distributed domain. They also expect, in our case, we heard loud and clear three things. First of all, event streaming. So no sane application developer today want to develop their own event streaming framework. A lot of people that are born and bred in the cloud rely on things like a Kafka or a Pulsar. Turns out that applying cloud-designed infrastructure components like Kafka or Pulsar in a super distributed fashion in resource-constrained environments is really hard operationally, particularly if you want to go multi-tenant. So what we did is that we built an event streaming API and an event streaming service in the Edge Enforcer that's multi-tenant, secure, and policy protected. So the person running this Edge Cloud can allow our particular applications or services or particular tenants access to an event streaming framework. And we've learned kind of by working with users that event streaming at the edge also looks a little different. The communication patterns are a little more specific than what is perhaps provided by the general event streaming frameworks that were built for the public cloud. Second thing, which came as a little bit of a surprise for us about a year and a half ago, was secrets management, right? No sane application developer today wants to manage code that life cycles sensitive material. Things like certificates, things like application credentials, right? They don't want to manage that. They assume that the infrastructure in the public cloud, again, has something like a CyberArk or a HashiCorp Vault. And when we looked at what that would look like in a very distributed fashion, of course, we realized that we have to think about how that works, particularly in offline fashion. So that's another application or another service that's provided by the Edge Enforcer as part of this running system or this integrated system. And the third one is we realized the hard way that if you are actually expecting cluster behavior in your distributed sites, and if you have an upstream outage, meaning you lose connectivity to the internet and you have a cluster failover, you're out of luck in terms of finding or pulling container images. So we actually needed a container image registry locally in the site that would cache the containers needed to satisfy what's running on the site at each point in time. So we've built one of those as well. So the Edge Enforcer not only, again, is part of our own infrastructure, but it's also actually provides a number of application and user-facing services, optional to use, of course, but that really lowers the barrier of entry for modern applications to be distributed and working nicely in edge sites.